Problem number 25. No, because we got to hurry up and get started on our work. Problem 25 is the lower half. So, problem number 25 wants us to find the lower half of the parabola x. Can you guys see that on the screen? Okay. Parabola is equal to y squared. Okay. So we want the lower half of this parabola. So now, this is a sideways parabola because it's on the screen. It's just the sun shining on it. Turn the lights off.
I mean, like, are you doing it on that thing?
I'm recording it, and you guys are just so loud and disruptive right now, and I'm just going to put it on the internet so that people can understand what I have to deal with on a daily basis. So anyways.
You just told us a story.
Oh, yeah, it's my fault that you guys can't behave. Okay, here we go. So y equals x squared is parabola, but when you switch it and you say x something 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 equals y squared, it turns the parabola sideways. All right. So what we can do is, the first thing we could do is graph this. All right. And so when we graph this, where'd my calculator go? So when we graph this, what is going on? See what you guys did? When you graph this, I need to remember we got to switch back and forth. So luckily I was doing pre-calculus last hour and I'm in function mode. So I'm going to graph, oh wait, I can't graph that the way it is, can I? No, I can't. So what do I need to do to graph that on my calculator first?
Maybe y equals the square root of x minus 1.
Yeah. So what we'll do is we'll just take the square root of both sides, right? And then I can get my Cartesian functions. So if I take the square root of both sides, I get plus and minus the square root of x minus 1 is equal to y. And so to graph that, I'm going to have to do two functions. So I come in here and I'm going to say the principal root of x minus 1. Right, that gives me the top half. And then I'm going to do negative of that, square root of x minus 1. And that should give me the lower half, right? Oops. And so I'm going to graph that. Okay, so that's what I'm looking at. Now we just want the lower half. So if I just want the lower half, bless you, if I just want the lower half, I could just get rid of that function there. And if I graph it, isn't that the lower half of the parabola? So that's really what I'm working with, right? What I'm really interested in is just y is equal to negative the square root of x minus 1. Okay? That's really what I'm interested in. That's what I'm working with. Now, what are they asking me to do in the question? So, let's see. It says we just need to write that as we need to go backwards now. We need to write that as the Cartesian coordinate. All right, so we're going to separate that into two Cartesian equations. Or not Cartesian, I said that wrong. Two parametric equations, right? So how could I do that? How could I do that? Well, we could do like a guess and check. So essentially when we look at this, what we want to do is I'm going to start with this. How can I guess what I want you guys to do is to try to think your way through this. What is the relationship between x and y? Yeah, well, no, just this is more of a conceptual thing. Don't try to come up with the answer. Just think about that. Yeah, so what I want you to do is we've got y squared is equal to the square root of x plus 1. Now the lower half of that is y is equal to negative the square root of x minus 1.
Why is the top one y squared? It's just y, right?
Well, yeah, because this is our Cartesian No. We're focusing on this root because we are instructed specifically in the question from the textbook to only concern ourselves with the lower half, and by looking at the graph we figured out that the lower half is represented by the Cartesian equation y equals negative x minus 1, or the square root of negative x, or I'm sorry, negative square root of x minus 1. Okay, so now how can I...
Wait, could you just like pull 2 points off of it and then plug it into the x equals blank plus at, y equals blank plus b?
The truth is there's several ways you could do it, but let's do it. Let's make it easy. Let's make it easy. Let's make the assumption. Let's assume. Now this won't always work, but I want to show you something. Let's assume that y equals t. So if y equals t, then what does t have to equal? Negative square root of x minus 1. So if this is my parametric equation for y, how do I get the parametric equation for x?
You do solve for x.
If I solve for x on this side. Does that make sense? Let's try. So if I square this and I square this whole thing, over here I get t squared is equal to, now when you square a square root you're left with the base and then the negative sign goes away, so we're left with x minus 1, right? And then what we want to do is we want to solve for x, so if I move the 1 to the other side I really get t squared plus 1. So now I have 2 parametric equations. I have y is equal to t and x is equal to t squared plus 1. Now I think one of you girls mentioned that you could try plugging t in for this and t, and you can. All those ways will work, and you might get 2 different parametric equations. As long as you use algebraic methods and you don't make any mistakes, it'll work. But the easiest way is to take either y or x, set it equal to t, and then figure out what t has to equal. In other words, I've got y equals some stuff. Well, let's make the stuff equal t, so then set t equal to that stuff. That stuff will have x in it, right? And then you solve for x. And that algorithm will work every time, okay? So anyways, this is where we're at. How do we verify to make sure that it works? Plug it into the calculator. So now I'm going to go into my calculator and I need to change my mode to parametric mode, right? So I'm going to come down here, select it, and then I'm going for my x function, we said it has to be t squared, right, plus 1. And then on the bottom here it just has to be t, right? And I'm not quite sure what we want to make this, but let's start t at 0 and we'll go to 1 and see what we get, okay? Uh-oh, what do we get? We got a little dot. So now what?
Now, you reset your window.
Yeah, we could reset our window. But the truth of the matter is we don't have a lot of values for t. So I think this is going to boil. I know algebraically this is the right answer. Let's make our minimum a negative number and see what we get. Okay? And the reason I say that is remember that we want the lower half of the parabola, so that means all of the y values would have to be negative, right? So I'm going to put in like a crazy negative number. So let's put in like negative 20. And let's do the maximum value. Now, the reason I say that is when t equals a positive number, what will the y value be? And that would put us in the upper half of the parabola, right? So the lowest value for t should be, or the maximum value, the way that we're doing it here, should be 0. Okay? And so now if we graph it, so how would we define what t should be? How would you guys go about doing that? First of all, is that the right answer?
Yes.
Yeah. Okay. So now we need to define what we want our t to be. So the last step is t is, how do I write that?
Less than or equal to 0.
You are absolutely correct.